Hi guys, today we're going to talk about conditional statements and Venn diagram. I know most of you guys learned about Venn diagram a few years ago, so we're going to just start with some examples. I want you to pause the video and work on the first 6 questions, and then we'll check the answers together. So pause the video. Okay, so these are the answers. Did you guys have the same answers as I did? Excellent. Before we move on, I just want to point out one thing. If you look at a Venn diagram that looks like this, one Venn diagram and the other one goes like this, and we have an intersection, and if this is set of A and this is set of B, then what can we say? We can say sum A R B. Is that right? So when can I use the sum? Sum can be used when we have two sets with intersection. How about this case? If we have something like this, this is set of A and this is set of B. Then what can I say? Can I say sum A's are B's? No. If you look at this, A is the subset of B. That means every A is B. So can I say all A's are B? Is that correct? So this is kind of common sense, but we just want to go over this to make sure everyone understands. We can also conclude that all A's are B, then we can change that into conditional statement and say if it is A, then B. Is that right? So if A, then it's going to be B. So we can change all A's are B into if and then statement, and we call that conditional statement, correct? Okay, let's move on. Okay, so let's recall the things that we learned from last class. So if you look at this, Fairfax County School and then Stone School, which one is subset of what? If you look at this, Stone student is the subset of Fairfax County schools. So can we change that into if and then statement? We just talked about it. So please pause the video and try to work on that question. Pause the video. Okay, so did you get something like that? If you're a student, then you are in Fairfax County Public School. Okay, so we can change Venn diagram into if-then statement, which is a conditional statement. And we learned that converse of a conditional statement is not always true. Do you guys remember conditional statement and its contrapositives are equivalent, and converse and inverse, they're equivalent. Okay. Now, in case where the converse is true, then original statement and converse can be combined into a single true statement called biconditional statement. We briefly talked about that last class. The conditional statement is formed by joining two parts of conditional with if and only if. All right? Okay. So let's take a look at the example. If an angle is right angle, then it is equal to 90 degrees. Is that right? That is true. And that is my conditional statement. If you look at the converse of that, if an angle is 90 degrees, then it is right angle. Okay? So in this case, the conditional statement and its converse, they're both true, then we can rewrite as a biconditional statement. So this is the P, this is Q. So we can make it into biconditional statement. We can say an angle right angle if and only if it is equal to 90. Okay, that is my biconditional statement. All right? Easy enough. Now, the second example is we're going to change the biconditional statement into its conditional and converse. So please pause the video and try to come up with two statements from this biconditional statement. Please pause the video. Okay, so these are the answers. If two angles are supplementary, then their sum is 180. If two angles are add up to 180, then they are supplementary. Pretty easy, right? And we can only change it into biconditional statement if the conditional statement and its converse is true. Okay, they have to be both true. Remember? Okay, let's move on to the next page. Okay, example 3. Math definitions are always biconditional. So, two lines are perpendicular if they intersect to form a right angles. Then its converse will be if two lines intersect to form right angles, then two lines are perpendicular. So its conditional statement, its converse is true, so we can change it into biconditional statement. Please pause the video and change them into biconditional statement. Pause the video. Alright, so the answer to this is two lines are perpendicular if and only if they intersect to form right angles. Okay, now we have some examples. Now we need to try these, but read the question carefully because you have to see if each conditional statement should be true, but you need to write the converse, and if the converse is also true, then combine the statement as a biconditional statement. If the converse is false, then you have to provide a counterexample. Okay, so I want you to pause the video and try question number 1 through 4, all right? And then we're going to check the answers together. Okay, pause the video, please. Okay, so example 1 was true statement for the conditional statement, but its converse, two angles are congruent, then they are vertical. That is not true. The converse was not true. It's false. So you can't make it into biconditional statement. The counterexample will be if two angles are adjacent to each other, they can still be congruent as long as they have same measurement, correct? But number 2, its conditional statement, its converse, they are both true, so we should be able to make it into biconditional statement. Okay. Number 3, we break them into the conditional statement and its converse. The conditional statement was true, but its converse was not true, because if you don't have a homework, that doesn't mean it's a winter break. It can be summer break, it can be holiday break, you know. Just thinking about break makes me happy, but you know, anyway, it's a false statement, so you can't really make this biconditional statement. Number 4, when you break it into original statement, but original conditional statement and its converse, both of them are true, so your biconditional statement was true. All right, let's move on to the next page. Okay, page 3. So as I mentioned before, Venn diagram can be in different shapes. The first type is no members in common. For example, no freshman is a senior. That means freshman and senior, they do not have intersection at all, and there are two separate sets. Now, if you look at these symbols, guys, we'll be using these symbols a lot. If you look at this V shape, it's gonna be or. If it's upside down V, then it's gonna be and. So what they're trying to find is A or B. Okay, that means A or B means it is or, so everything. Okay, but A and B, do they have any intersections? A and B, they have nothing in common, so A and B doesn't exist for this one. Okay, how about some members in common? What does that mean? Some football players are baseball players. That's where we have intersection. So A and B, they do have intersection. Okay, so what does that mean? A or B, this is or, so union of it all together. So how do you make the shades of everything all together? We just make everything all together like that. Okay. Now, next one is A and B. That's the intersection. A and B, they have something in common. They do have something in common, which is right in the middle. Okay. Easy. Now, third case is all members are smaller group of within larger. What does that mean? The one is the subset of the next one. The Stone 8th graders are all Stone students. Okay, so that's the subset of it. So how do you make the union, which is or A or B? That's gonna be, let's say this is A and this is B, then A or B will be B. Is that right? It's gonna be B. And then A and B will be, what do they have in common? Which is A. Okay, so this is very, very straightforward. Okay, so we already talked about all and some and none. Okay, I want you to think about these. We went over this briefly. I want you to go over these examples and try it by yourself, and then we'll check the answers together. This is pretty much common sense, so think about it. All right, pause the video now. Okay, so these are the answers. If you have any questions, you can bring it to class next week. Next class, we'll talk more about that briefly before we start the next section. All right. Also, there's a last page. I want everyone to try it, and then we'll actually go over the answers in class. So that's gonna be your homework as well. All right. Then I'll see you in class. Have a good day. Bye.